Okay, so we did the pre-calibration. Let's move on now to the calibration. Let's see what the machine actually tries to tell us with respect to the calibration. So first of all, we actually need to focus on the supply area. And what we see here is, at this stage, the machine detects 40 Pascal of counter pressure in the ducts, so in the whole system, and actually the fan is at 64%. So the important thing when calibrating is actually to start always with the vent with the highest counter pressure and the highest airflow. Okay, highest counter pressure, highest airflow. Because the reasoning is, when the machine can reach the desired and required airflow in that vent, it can reach it anywhere. So that's quite important. So in this particular setup, the vent with the highest airflow and the highest counter resistance is this one. So let's see how much airflow we have with our flow meter. Remember that we said that here we needed approximately 50 cubes an hour, and we are actually at 62. Look, we're at 62. It's obviously fluctuating, but we are a little bit too high. So what we will do is basically slow down the fan so that we reach 50 cubes as opposed to over 60. There's two ways we can do that. Either if there's a remote control in the neighborhood, we can push here to go down or push there to go up. So basically that serves as an instrument to settle the fan speed. Or if there's no remote control available, we can actually do it on the display of the unit itself. So here again with the arrow up or the arrow down. Okay, so let's see here, we were 60 cubes and we want to go to 50 cubes. Approximately each time you press the button, it's approximately 2 cubes that go down. Okay, so I've pushed now and I've lowered it to 30 Pascal. We will see how much airflow we have now. By the way, which is interesting, I don't know if you can see, but the remote is blinking very fast now. It's blinking yellow and now it's stable. So this means that actually the unit has changed the fan speed, but it obviously needed time to stabilize throughout the system. Okay, the remote control gives you an indication when this is done and when you can actually start measuring the airflow. If you don't have a remote control in the neighborhood, don't worry. If you wait approximately 10 seconds, the system will have stabilized. Okay, so let's see how much airflow we have now and whether we are closer to our target of 50. Actually, I'm doing really well because look, we are at 51 or something. 50-51. So that is really good. So this means that actually we have set the fan speed of the machine such that the desired required airflow in this vent, remember it was the vent with the highest airflow and with the highest counter resistance, is met. Okay, so now we don't touch the machine anymore. Now we actually do fine-tuning at every vent. So let's see how much we have here. So this was a bedroom, as we said earlier, and we wanted to have 40 dB. Well, at this particular point I have over 90, so that's way too much. So I need to create a lot of counter pressure here to make it go down. So let's put in some extra mousse to create some counter pressure. Voila. Again, you will see that the machine has detected that the counter pressure is changing in the system because I opened it up, I put the mousse in, I closed it down again, so the machine is now going to find a new point to keep actually the same pressure in the system. And normally we will see that here it's still 30 Pascal. So you see the system has kept the same pressure in the system. And the fan speed on the other hand has gone down to 54. All right, so that is the mechanism of actually calibrating under constant pressure. The system will adapt to keep that same pressure, in this particular case of 30 Pascal. So let's see how much we have here now. So this should have gone down. It was, what was it again, in 80s or 90s? 90. Well, obviously I've managed to pitch a bit off, but not everything, so we're still at over 70, right? Or almost 70. So I'm going to further block this, and the way I do this now is actually by closing off closing the opening. All right, so this is how we do it. And let's see, this is obviously always a little bit of trial and error. I'm just guessing now. You see again, I've increased the counter pressure, so it starts flashing again. So again, the system is adapting its fan speed to keep the same pressure in its ducts. So I give it some time, again, for approximately 10 seconds. Voila, the light has stopped flashing, so this means that the system is stable and that I can do a new measurement in terms of airflow. So I wanted 40 here, it was 90. It went down to 60, I believe, and we're now at 54, which still is a bit much, so I will go further. This is, like I said, it's a bit trial and error. And obviously people, as they get more and more experienced, they will do it quicker. So again, let's wait 10 seconds. We will get there. Voila, there he goes. And hopefully we get closer to where we want to be. And actually we are. Oh, I did it a bit too much now, but we're at 38, 39. Okay, so we are extremely close to the 40 cubes that I wanted to have. So we've actually managed to calibrate this vent particularly well. The whole magic now is, will the airflow in this vent have changed? Well, the answer is no. This is the promise that we make, and this is why this system with calibration under constant pressure is so unique and saves so much time for the installer. In normal systems of MVHR, this will now have changed and you will have to do the tour a couple of times. With us, normally the airflow will have stayed the same. Let's look whether that is the case. And indeed, we are still very close to 50 cubes an hour, right? So that is the big advantage of a calibration under constant pressure. The machine itself adapts itself, it reacts to the increase of counter pressure, it lowers down the fan speed so as to keep the airflows, the required airflows in each and every single room. And if we look at where we are now, you see that indeed the counter pressure in the whole system is still 30 Pascal like it was originally, and the fan speed has actually slowed down to 54%, allowing for the correct airflows to be reached in the different vents. And obviously you do the same with the other vents in these supply areas. And then you do the same with respect to the extraction zone.